How many different sums can be obtained by adding any two different integers chosen from this set of 35 consecutive integers from -17 to +17? So we are interested in the number of different sums that can be obtained. And the way we obtain a sum is by picking two integers from the given set. For example, if we pick the integers 2 and 3, then we get a sum of 5. If we pick the integers -17 and -13, then we get a sum of -30. If we pick the integers -15 and 15, then we get a sum of 0. So notice that these sums are all different, but if we had picked the integers 4 and 1, then we would have again got a sum of 5, which we got here as well. If we had picked the integers -1 and 1, then we would have got a sum of 0, which we also got here. So the question is, how many different sums can we get in total? Now some of these sums were positive and some were negative and some were 0, of course. But instead of focusing on both positive and negative sums, let's focus only on positive sums to start with. Let's try to find out how many different positive sums we can get. The number of different negative sums we can get will be exactly the same, because the choice of numbers that's given to us is symmetric. That is, if the number n is available for us to pick and choose, then so is the number -n. It is important to keep an eye out for symmetry in problems. So if I can add 4 and 1 to produce 5, I can also add -4 and -1 and produce -5. If I can add 13 and -4 to get 9, then I can also add -13 and 4 to get -9. So every time I choose numbers a and b to form a positive sum s, in principle I could have also chosen the numbers -a and -b to form the negative sum -s. So if I can find out how many different positive sums I can form, that would also tell me how many different negative sums I can form. So how do I find out the number of different positive sums I can form? Well, let's try to identify the smallest possible positive sum we can form. What is the smallest possible positive sum? Well, the smallest possible positive sum is 1. What is the largest possible positive sum? Well, if we want to form the largest possible positive sum, then we should pick the two largest integers in the given set. So those are 17 and 16. And so the largest possible positive sum we can form is 33. So any positive sum that we can generate from the given numbers must lie between 1 and 33, including the two endpoints 1 and 33. So the question is, can we generate all the numbers between 1 and 33 as sums, or can we generate only some of them? We need to find out how many of these 33 sums are theoretically possible to generate using the given numbers. Can we generate all the numbers between 1 and 33 as sums? Well, let's look at the numbers 1 to 17 first. We can generate any number from 1 to 17 as a positive sum. How do we do that? Well, we simply pick this number from the given set along with 0. So, for example, we can generate 5 by picking 5 and 0 in the given set. We can generate 7 by picking 7 and 0. We can generate the number 17 by picking 17 and 0. We can generate the number 1 by picking 1 and 0. So all the 17 numbers from 1 to 17 can be generated as positive sums. Now let's look at the numbers from 18 to 33. Remember that 33 is the largest possible positive sum. Can we generate all of these numbers as positive sums? Well, since all these numbers are larger than the largest integer we are supplied with, which is 17, let's say we were to pick 17 as one of the numbers that we'll be adding. So we can produce a sum of 18 by adding 17 to 1. We can produce a sum of 19 by picking 2 as the other integer. We can produce a sum of 20 by picking 3 as the other integer, and so on. And we can produce a sum of 33 by pairing 17 with 16, as we've seen before. So all the numbers from 18 to 33 can be generated as positive sums. So all the numbers from 1 to 33 can be generated as positive sums. It is always possible to pick two numbers from the given set such that they sum to any number that we want from 1 to 33. And by the same exact argument, symmetry tells us that all the negative numbers from -1 to -33 can be generated as negative sums. It is always possible to pick two numbers from the given set which add up to any arbitrary number in this set. For example, if we want to generate -18, we can generate it by picking -17 and -1 from the given set. If we want to generate the number -5, we can do that by adding -5 and 0 together. So we can generate positive sums from 1 to 33 and negative sums from -1 to -33. So together these are 66 different sums that we can generate using the integers that are given to us. And we can also generate a sum of 0. So this means the total number of different sums that we can generate from the integers that have been given to us is 66 plus 1, which is 67.